0, 4, nth roots and real exponents. So first we're going to look at finding nth roots, and you'll notice that these first three examples only have numbers. We have no variables involved here. So if I am taking the square root of 81, I might remember that 81 is 9 squared. Let's grab a marker. And so if it's 9 squared and then square root, I would just have a -9. Now with 81, I don't think you need to do that, but it might help as we get to higher powers. So 16 I know is 2 times 2 to 2 to the 4th. 625 is 5 to the 4th. So when I am doing the 4th root of 16 divided by 625, I will just get 2/5. And then on my last one, I notice that I have an even root, but my number inside is negative. And so this is not a real number. I cannot take an even root of a negative. So I would write no solution. It might be also helpful to notice that I know we have talked about when x is squared and we take a square root, we have an absolute value. And that's because we don't know what x is. So if I have 9 squared and I take a square root, I know that it was just a 9. So it's just the number 9. So when we're only working with numbers, we don't have to worry about absolute values or plus or minus or anything. So on the next page, we're looking at different roots, whether they are even or odd, and then what happens. So if we have an even root of a number and it's positive, then we need to use our absolute value signs. And we have one positive and one negative answer. If our root is odd, then we just have one positive answer. And these are real roots, so we should probably say real. It doesn't give me anything imaginary. If I have a negative, but my root is even, then I have 0 real roots. But if my degree is odd, if my root is odd, I guess I should say, then I would still able to take that root. So I would have one negative real root. And if a is 0, well, if I have the nth root of 0, it's just 0. And that doesn't matter if it's even or odd. So we would get one root, and it's just 0. So you can see that this is a little bit more complicated than maybe what you've done with radicals before. So now we're really looking carefully at that, how many answers, even or odd, we're thinking about all those things. So here's a few that we're going to simplify. If I have b to the 24th and then the 8th, this b could be to the 3rd and then the 8th, right? 3 times 8 is 24. And so my 8th roots would cancel, or 8th power, 8th root would cancel. And so I have b to the 3rd. But then what I need to think about is I have a variable, and it was an 8th root. That's an even root. And so I need to have an absolute value at the end. And that makes sense because if I cube a negative number, it'll be negative. If I cube a positive number, it'll be positive. There's different things that could happen there. My answer could be positive or negative. On the next one, 48x to the 5th. So often we've broken this down. 48 is 16 times 3. So 16, 3. X to the 5th could be square root of x to the 4th, and then square root of another x. Square root of 16 is 4. Square root of x to the 4th would be just an x squared, because x squared times x squared gives me x to the 4th. And then I'm left with the 3 and the x inside my square root. And on this one, I don't need an absolute value because x is being squared. So if it was a positive number and I square it, now it's still positive. If it's a negative number and I square it, it's still positive. So we don't need an absolute value sign there. For 6, let's see, 64 is 2 to the 6. I call it 6, but it's really not. It's just the 6th root, right? 64 is 2 to the 6th power, and then y plus 2 let's see, that would be 5 times 6 power, right? So let's do this. So this would be 2 times y plus 2 to the 5th. And I would need those absolute value signs again around the y plus 2 to the 5th. Not around the 2, because 2 is just always positive, but around the rest of it. So this one's a little more complicated. I am looking at a very strange root. Let's see. Cube root of negative 27. That's just going to be a negative 3, isn't it? I'll have a cube root of a to the 6th. I'll have a cube root of b to the 3rd. It doesn't look like a b there. It looks like a 6. And then the c to the 5th, I'm going to make it c to the 3rd times the c squared. And these are all cube roots. So let's see, cube root of negative 27 is a negative 3. I would have to multiply an a squared times an a squared times an a squared to get that. So this is a squared. This one's just b and c, and we still have a cube root of c squared. And because I have an odd root, no absolute values, nothing to worry about. So now we're going to look at expressing roots as exponents instead. Just review that really fast. So if I have b to the 1 over n power, that's going to be the nth root of b, because b is to the first power. And then m divided by n, that exponent is going to be either the nth root of b to the mth power, or the nth root of b to the m power. And just remember, this is only if m over n is in reduced form. We always want to make sure that we've reduced the exponent, just like a regular fraction. So here's a couple to look at and think about. I know that I should not have, with this first one, square roots in my denominator, but I can also tell 25 and 5 have something in common. So instead of rationalizing right away, I really want to break this down. So right now I have the 4th root of 5 squared. And then I have the 6th root of 5. So I'm going to write them both as exponents instead. 5 to the 2/4 power, 5 to the 1/6 power. I can reduce the 2/4. This is a lot of steps, but they're pretty short, easy steps. At this point, I know that I can take, since I have the same base in the numerator and denominator, I can subtract those exponents. And so this would be 5 to the 1/2 minus 1/6 power, which is going to be 3/6 minus 1/6, or 5 to the 2/6 power, which is just going to be 5 to the 1/3, which we can write as the cube root of 5. On the second one, we're going to do something similar. I'm going to write this as x to the 31/6 power times y to the 26th power. And I'm going to look at breaking those exponents apart. This would be 30 over 6 times x to the 1/6. So I'm breaking it into things that I can divide, right? It's almost like looking at a, really we could just look at it and kind of skip this step as a mixed number. So 6 divides into 30 5 times, and I would have 1 left over. So x to the 5th times x to the 1/6. And then 6 divides into 23 times with 2 left over. Oh, and that's a y. Let's fix that. So times y to the, let's see, we had 2 left over, so 2/6 power. So now my whole things I want to take in front. And remember, this was an even root, so I'm back to needing absolute values around my x fifth and y cubed. And then I have a 6th root now. I don't want to simplify that power because then it can't go inside this 6th root. And I'll have x to the 1st in there and then y squared. So please go ahead and complete the 0-4 homework. This is an assignment where you really want to be checking your answers as you work and making sure that you're not forgetting about those absolute value signs. What you're really going to see is when we have an even root and we have variables and then our exponents at the end are odd, that's when we've got to have those absolute value signs. So just really watch out for that.